Okay, hello everyone. So in this video we are going to discuss about the logarithmic differentiation. Okay, natural logarithmic differentiation. So here we are going to apply all those four properties that we have discussed in our videos number 2, okay, on the week 1. So let us try to recall it again. Let's say here if you have the value of ln a dot b, we are supposed to get it as ln a plus with ln b. Number 2, if we have here ln a over b, we are going to get it as ln a minus ln b. Number 3, the third properties that we have here is, if you have ln 1 over b, basically we can get here as negative ln b. Okay, I think I already show you how you get the things here. Number 4, when you have the ln a with a rational number there, so you're going to get here r ln a. Okay, this is supposed to be r. So this is the formula. I think it's better for you to write it down, because after this we are going to utilize it in our calculation. Let us see here, we deal with what we call it as example number 1. So you can refer the same example here in your notes. Okay, example 1. Where you have here the value of your fx is now equals to 6 minus with 4 x to the power of 2 power of 8 of everything here, and then you're going to multiply it with the square root of 6x to the power of 2 plus 8x, then you are going to minus it with 12. Okay, if you look into this question, if you want to find the question of, or the answer of dy over dx there, okay, it will very tricky there, because you need to deal with a product rule, and sometimes you need to deal with a chain rule there. So in order for us to simplify it, we are going to use a technique called as the logarithmic differentiation. So let's say here we want to apply the logarithmic differentiation. So what we can do now, if we want to apply this technique, is that, so let me erase this part first. Okay, what we can do now is, first, let us try to put ln for both sides. What I mean by both sides, this is your right hand side, this is your left hand side. So we have two sides here. So what we can do here now is, first, try to put ln for our both sides. So you are going to get here ln of fx is equals to ln 6 minus with 4 power of 8. So you have 6x power of 2 power of 8. And then the square root here, I think it's better for you to write in terms of power, where you are supposed to get here 6x power of 2 plus 8x minus 12 power of 1 over 2. Okay, or you can see it is power of half. So what you can do here now is, you can apply the properties for this part. Okay, if you still remember the four properties that I introduced you just now, so here we can actually apply the first properties, where you have your ln a and b, where you can put it as, okay, let me put here ln fx. You can change it into ln y, because fx is the value of y there, equals to, this one you can refer to the formula of ln a dot b there, which is you can change it to ln a plus with ln b. So here you can imagine that this part is your a and this part is your b. So you can write it as ln 6 minus with 4x to the power of 2 to the power of 8 plus with ln 6x to the power of 2 plus 8x minus with 12, and then it is power of 1 over 2. Okay, next, what we can do here, we can apply the property number 4, which is, if you still remember, ln a power of r, you can change into r ln a. So here, this is ln, this is your a, this is r. So you can change it into ln y equals to 8 ln 6 minus with 4x squared plus with 1 over 2 ln 6x power of 2 plus 8x minus 12. Okay, so when you already utilize all the properties, what you can do here, you can start to differentiate here. Okay, so I think you should know how you differentiate this thing. Since I don't have enough space for my whiteboard here, so I think it's better for me to erase this part. So let me erase the first step, and also when you apply the second step here, also let me try to erase it, because we want to see how do we do the differentiation. Okay, so let me continue here. So differentiate ln y with respect to x, you are going to get 1 over y dy dx. Okay, you try to differentiate this thing, you are going to get this one, equals to 8 here, you write it again. And what happens if we try to differentiate this part? Okay, again you need to refer to the formula, last week formula, which is you are going to get here 1 over u, which is you are going to get here 1 over 6 minus 4x squared, and then differentiate the value of negative 4x squared. Here you get here negative 8x, and then plus with 1 over 2, you write it again. And from the ln up until this part, you try to differentiate it by using the formula. What is the formula of differentiating ln? You are going to get here 1 over 6x to the power of 2 plus 8x minus with 12. Then don't forget to differentiate all this term. You are going to get here 12x plus 8. And if you differentiate minus 12, you can get 0. So just leave your answer like that. Okay, so you can pause this video and try to see how do I do the differentiation here. Okay, so look back, what is the formula of ln u if you differentiate. Okay, I think you need to refer to your notes there. Okay, so let me erase this part because I need to have a few more space for me to conclude my calculation here. So then try to simplify and then bring the value of your y to the other side, because our objective is to find dy dx. So dy dx is equals to y bring to the other side, so it become y multiply with, so 8 times with 8 here, you are going to get negative 64x over 6 minus with 4x square. And here 1 over 2 multiply with 12 becomes 6, multiply with 8 become 4. So you're going to get here plus with 6x plus with 4 divide by 6x squared plus 8x minus with 12. Okay, so here the value of y is actually referred to this value. So just copy again all this value and then you can stop, I think. So just copy it again. So you copy again the question because the value of y here. So you're going to get 6 4x squared power of 8 square root of 6x squared plus 8x minus 12. And then write again all this term. Okay, put it somewhere here. Okay, and then finish. Okay, if you can simplify further. But for me, it's enough for you to, if you just put it like that. So I know that the method is there. Alright, so this is the things. You can try to deal with the rest of the example there. Okay, so see you in the class next week. Thank you, guys.